Thank you, everyone, for joining. So my name is Koji. I'm co-founder and CEO of Key Hydrogen, and together with my co-founders Carl and Michael, we are solving green hydrogen's energy problem. So for those of us in the climate space and energy space, I think we hear a lot of hype and kind of noise around hydrogen, all the things it can or it can't do. But for us, it's really important to keep in mind that hydrogen is nothing new. The world already produces 94 million tons of hydrogen every year. That goes towards kind of ammonia-based fertilizer, and essential fuels and chemicals. The issue is over 99% of that is from fossil fuels, or what we call black or gray hydrogen. And that leads to direct emissions of over 830 million tons of CO2 every year, which is comparable to the emissions of the entire aviation sector. The clean solution is green hydrogen, so producing hydrogen without carbon emissions. Today, the only commercially available way to do this is a technology called water electrolysis, which uses renewable electricity to split water into hydrogen and oxygen. The issue is it's about 3 times more expensive than gray hydrogen. And the reason that is because it's so energy intensive. In fact, the energy requirement is about 70% of the levelized cost of the hydrogen production. So to bring down the cost of green hydrogen, we have to tackle the energy problem. But the incredible thing is most of that energy is actually used in producing the oxygen, which is the low value part of the reaction, and many times it's just vented away. So what if we can replace that side of the reaction with something that's more value add, but also much less energy intensive? And that's exactly what we're doing. So our patented technology is called biomass electrolysis, where instead of taking water as a feedstock, we take liquid biomass, and that can be waste from breweries, paper pulp, even down to agricultural waste. We feed that through a direct electrolysis process, and we're replacing that. Instead of producing oxygen, we're now breaking down the biomass into chemical co-products like acetic acid and formic acid, which are commodities that we can sell. But also, this reaction is much less energy intensive and requires about 75% less energy to produce each kilogram of green hydrogen. That means we can get to cost parity with fossil fuel-based hydrogen down to $2 a kilogram. We are the only low-energy, zero-emission hydrogen production technology. That's compared against methane pyrolysis, which still has significant emissions at methane extraction and leakage, and then gasification and microbial, which produce a mixture of gases like carbon monoxide and carbon dioxide, which need to be separated and sequestered. So as I mentioned earlier, the world already produces 94 million tons of hydrogen. That equates to an existing market of $150 billion. So if we can capture 5% of our addressable market, not only is it a massive 2.4 billion opportunity, but for us, very importantly, it's a massive carbon opportunity, where by displacing gray hydrogen with cost-competitive green hydrogen, we are mitigating 100 million tons of CO2 every year. That's equivalent to about 50% of London's annual emissions. And we're not the only ones to realize this opportunity. Governments and economies around the world are pouring billions, just within the past 2 years into accelerating specifically green hydrogen technology. And what we're particularly excited about is the EU just this month set binding targets to convert 42% of their gray hydrogen to renewable by 2030. Today, they're about 0%. So it's an entire market for the taking for whoever can crack cost-competitive green hydrogen. And we have just a team to bring you this technology. So Michael, our CTO, did his undergrad at UPenn, PhD at Cambridge, and continued on doing his postdoc research on novel waste-to-hydrogen technologies. I've seen hydrogen at the largest industrial scale during my 6 years at ExxonModbil, where I worked on an $800 million hydrogen project, the largest in the UK. And we have Carl with his multidisciplinary PhD, over 10 years in startups, and especially specializing in bringing technologies through IP, MVP, and deployment. And we have a great set of advisors covering management, regulatory, research, and investing. So some of our traction to share, we've won funds through grants and competitions, including being one of 8 global finalists at the MIT Climate and Energy Prize. We're also one of 10 startups out of 250 applicants that got invited to pitch at Hack Summit later this year. We joined the Undaunted Climate Tech Accelerator. We have our patented IP, and we're now testing our technology with some of the world's largest biomass producers. Our business model is an asset-light technology licensing model. So breaking out into kind of 3 steps. So we will get into the lab for the next 2 years, expanding out the IP, testing the technology on real-life industrial waste streams. We'll move on to an on-site pilot with breweries being our beachhead, where we can produce hydrogen from their waste. And the companies we've been speaking with have already been looking at using hydrogen on-site to decarbonize some of their industrial heating. So that's a nice closed-loop solution. But we know to scale this up, we want to focus on what we're good at, which is we're a technology company. We don't want to become a logistics company. We don't want to become a manufacturing company. So we'll partner out those asset-intensive pieces and focus on our expertise. So we're currently raising £1.5 million to fund us through our 18-month timeline, where we can get to pilot ready and start the engineering on it, during which we will expand our IP portfolio, build our lab demonstrator using real-life waste streams, and eventually get to TRL 6, where we start getting much more industrially relevant and building the pilot. So we're very proud of the progress we made for the past 5 months, but we're just getting started. Thank you so much for listening. We're at Key Hydrogen.
Quick question to start with. Could you give a bit of background about where your IP comes from?
Yeah, so our IP is actually licensed from our academic partner in NTU Singapore. Dr. Lee Hong on our advisor board was the original researcher there. And we found a great opportunity to kind of collaborate and help them get that technology from what they were doing in the lab out somewhere it can deploy, like in the UK. Singapore has some limitations because lack of renewable power, things like that make it a good opportunity to move somewhere else in the world.
Okay, cool, thank you. My next question is kind of about the scalability of your tech, if you could explain a bit. So I think you mentioned is basic, it's similar to electrolysis. So is that basically several pieces of technology that you combine with electrolysis? So it's like sort of similar scalability in the future?
Yeah, so we're looking at these kind of very modular systems that are now being produced in terms of electrolyzers. So that allows us to start with something that's only a few £1,000 and build something in the lab, make our technology work with existing electrolyzers that are manufactured at scale anyway. And then it's kind of like that server rack design. So once you've made it work for that one small sheet unit, something that's like the scale of a PC, you can just stack that infinitely, and that's how we get our scale, through partnering with those companies that are already manufacturing those electrolyzers.
Yeah, and to really reiterate, it's about the advancement, like you kind of referenced in the last decade or so, in the supply chains of electrolyzers, really bringing out, en masse electrodes, separators, the kind of materials that we're going to leverage in our system, which will allow us to hopefully, use the combination of modularity and some of the manufacturing designs that have already happened to build up quickly.
Okay, perfect. And so just follow up on that. So like in your presentation, you mentioned that you would be able to reach $2 per kilo as a sort of unit economics. So like, is that just basically thanks to your production process, or does that also take into account some, carbon credits or like other things?
So it doesn't take into account any carbon credits. It does take into account the chemical co-products that we're producing. So as Koji mentioned, in the new oxidation side of the reaction, we're turning our biomass feedstocks into chemicals like acetic acid or formic acid, and that helps with the balancing out some of the costs of the waste acquisition, the treatment in there, and it's kind of that combination that gives us the ability to sell these two products and especially get hydrogen to that market competitive price.
Okay,
So the nice thing with those co-products as well is they're derived from fossil fuels at the moment. So you're kind of playing into this whole industry that needs to change in terms of grey hydrogen, but also things like acetic acid, that you need green chemicals to go with it. So the partners that we're looking at are also players in both of those spaces as well.
And the last thing I'll add is on that $2 a kilogram. So that's assuming electricity prices of $70 a megawatt hour, which when you compare it against like water electrolysis, when they have their cost curves down to $2 a kilogram, they have to assume electricity prices of like $15 or $20 a megawatt hour, because they physically can't get to $2 with electricity prices around 70. And maybe you can get 15 or 20 in places like Australia or Chile, but in many places in Europe, we just don't see electricity prices, or we don't, anticipate electricity prices to go down to that level.
Okay, so that's kind of your worst case scenario.
Yeah.
Okay, thank you. More on the customer side, so you mentioned like breweries, but more generally, like what's your ideal type of customers, and also like is it related to also the type of sites where you have like basically the type of available sites you have to install your production reactors?
It's an interesting question because I think in the sort of short term we're looking at those easier waste streams, so things that are already wet where they're struggling to, the co-products that they're making at the moment are kind of like animal feed and they have to dry their waste streams, so like from sugar manufacturing or paper. But ideally we want a customer that doesn't actually necessarily want hydrogen. So then you're looking at sort of crop waste and residues and these waste streams that are much harder to sort of get hold of, that no one really has an answer for what they want to use it for at the moment. And then you've got that hydrogen that you can use then to displace grey hydrogen.
Yeah, I think following up on that, there's kind of two phases there where one, in the initial piloting step, we're looking at, as Koji mentioned, the closed loop on-site, like there's a biomass producer, everything in one spot, you have your biomass and a need for hydrogen likely through heating. Long term, because of the challenges around hydrogen infrastructure, we would look to have the main customer be the hydrogen off-taker, so whether that's chemical production or things like that, and then use existing supply chains that are out there for the movement of biomass to then source that and bring that to your hydrogen off-taker, which is easier than taking your hydrogen and carrying it somewhere else.
Okay, thank you. Last question. So on the last step of your sort of business model, like business roadmap, you mentioned so you wanted to switch to a licensing model. So who would be your typical partners in that model?
So that's going to be the OEMs really of these electrolyzers. So your Topsoe, Siemens, even people like Anapta, those kind of players are really like. So they've got a problem with deployment at the moment. Of they can make these things, but because the green hydrogen is so expensive, like they're just not getting the orders they need. They're not seeing this in the real world, and essentially we can introduce a whole new class of customers that they just wouldn't have access to otherwise.
Okay, perfect. Thank you very much.
Thank you.